I'm going around. Malachi, you don't want to go that way, Malachi.
We're coming, Kevin. Sorry.
The dog has had trauma in his life, and as someone that also has had trauma, I don't want to traumatize the dog.
Okay, so they can't see Kevin yet. Let me get all the labels set up if you want to introduce yourself while I set up all of Kevin's labels.
Okay, so hi, I'm Annie. I know enough about astronomy to be dangerous, but I geeked out when I saw that you processed images, because I also kind of sort of sometimes process images. Not Cassini though, because Cassini has kind of terrified me. So it's usually been Hubble. Yeah.
Okay, you're now both up on screen. Okay.
Okay.
Go ahead. Talk at will.
Hi. I don't know if I can hear him yet.
Can you say something, Kevin?
Okay, good. Can we turn up his volume?
Yeah.
Okay.
It's not getting picked up, but Kyle's playing guitar upstairs. Because we told him it wouldn't get picked up.
We forgot about us. Okay, you are now cranked up all the way.
Okay. Ta-da!
Can you say something, Kevin?
Something?
Down just a tad. Just a tad.
Okay, you're now halfway between.
So for everybody else, like, Kevin is here, but the camera is here. So for nobody else but my own weirdness, I'll just stare at the camera. So just know, Kevin, I can't see you. I can see you out of the corner of my eye, but for everybody, I'm just going to stare at the camera. And she's still updating things.
Yeah, but they can't see it, so you're good.
Yeah. So I guess go ahead and introduce yourself, because I swooped in at the last minute.
Okay, I'm terrible at self-introductions, but I'm Kevin. I'm an engineer, software engineer at NASA's Jet Propulsion Laboratory, mostly working on the sea level data analysis tool and other climate-related things, along with a methane source tool that just went public pretty recently. On the side, though, I'm doing a lot of image processing and computer graphics, just kind of anywhere but Earth thing. So I've done a lot of Cassini, Juno, Galileo, Voyager, dabbled in some Hubble and MSL and whatnot. Whatever I can get my hands on.
Cool. So what was the path that you took to get to your current job? Because I know some of our community members are very much NASA fans and also into computer science.
I didn't start out that direction. I've always liked astronomy and the sciences. I was in the Marines the first thing I did out of high school. And did 4 years there, went out and then just started as a stock trader with Fidelity. And then finally went to college and did my undergrad and a master's degree in computer science. And then kind of worked my way over into software engineering. And then just kind of, I don't know, just got sciencey about it. And eventually NASA came knocking.
Oh, so NASA came to you. You didn't go to NASA.
Yeah, it was kind of a two-way street, but yeah.
I mean, I'm sorry. My brain is taking a second to process. So did you do, because I know I only have my undergrad in computer science. I have not gone on to masters for a variety of reasons, including my sanity. So computer science masters, did you do a project? Did you have a thesis? Did you just take classes? Do you mind talking about that for a little bit?
Yeah, a little both. It was at Riviera University in Nashua, New Hampshire. And it was a series of classes mostly. Just kind of your standard post-grad classes, I suppose. There was a thesis which was in the form of a software project, which I ended up writing a tool which created digital elevation models, mostly from USGS surveys of Earth at that point. So it included its own software renderer. It did all the reprojection and whatnot that was necessary to do 2-dimensional and 3-dimensional rendering.
Oh, wow. That's so cool. What language was it in?
What language wasn't it in? I ported it a couple times. It started out in C. I started out in C, then went to Python, and then finalized in Java. Because I kept rewriting it.
Okay.
Basically the fun of it.
For the fun of it?
Continued.
For the fun of it.
Yeah, the official project for the class was in C.
Okay.
Yeah, and then I rewrote it a couple times, and the final version of it was in Java.
Any particular reason why it ended up in Java?
Simplicity.
Okay.
Python's math processing isn't too quick, other than using NumPy, and just for the rendering, it didn't kind of work out. And I just ended up doing Java. That's kind of where, at the time, most of my strength was. So I kept it there, and I could build it out with a better, user interface and all that stuff. Because for the final project, that was just a command tool. With Java, I was able to build out an entire user interface for it.
That's actually super cool that you were able to expand to the entire UI.
Yeah. And then I threw some other fun stuff with it as well, because then you could do, bring in not just the elevation models, but actual satellite imagery. I built a scripting tool into it so I could add stuff to it. I actually got it as far as I was able to render the entirety of Mars, and then just had fun. I added clouds and oceans and all that stuff, which was that was.
Kevin,
that was this one. If you ever seen that, or
tell folks about your SpaceX discovery earlier this week.
Yeah, back in the day, not long actually after this, SpaceX came and wanted a render of Mars, and doing it as terraforming. So I did that up and sent that over to them. And actually, that was rendered in that software, because that was that long ago. I believe it should probably still mounted on big old canvases outside Elon Musk's office, which is pretty cool. And then I guess they just started using it for the live streams. I don't know if it's only that one or if they'll go back to the original ones that another guy made.
That's still pretty cool.
Yeah,
it's still pretty cool. It's this little project, your thesis project, that you just redid in Java for fun because Python isn't all that can be cracked up to be, and it ended up being part of essentially wall art and background art for SpaceX. That is super cool. Yeah, it was neat. And then the software kind of went by the wayside. I just ran out of time really to work on it. And then I kind of moved on to doing web apps, playing around with WebGL and all that, web browser stuff. So can you briefly explain what WebGL is?
WebGL is pretty much an extension to JavaScript for rendering 3D graphics in the browser. So where like HTML5 canvas is 2-dimensional, you can use WebGL to do games and whatever visualizations you want to do, or OpenGL type stuff within the browser. Just basically gives you OpenGL hooks into JavaScript. And there was this great library for doing it. It was 3JS, which really made it pretty easy to write. I started off with this one little scale planets thing, and I was rendering just a big giant sun and all the planets to scale, and you could play with it and whatnot. Realized that this is something you actually can do it, play with. and then I made that Planet Maker app. Now, Planet Maker you just start with Earth.
Right.
And anything, I kind of probably made it a little more complex than it needed to be, but anything that I could do in OpenGL where I could swap out textures or change the color of this or the height of that, anything I could do programmatically, I created a UI element. So you could just do it, you could just create the planet and just mess with it. So you could take Earth, remove the clouds, add different clouds. You could change Earth to Mars or any other planet that it has. Add moons, rings, all the fancy stuff. It was a fun little tool. I haven't touched it in a couple of years.
Is it still out there on the interwebs somewhere?
It is. I'm gonna move it to a static site though, because I just haven't been maintaining it. But it gets usage, so I feel bad shutting it down because if I go on the Google Analytics, a lot of the users are like school districts. So I figured they probably have it built into some lessons or something. And I don't want to take that away, so I got to figure out something to do with it.
Yeah, I bet you somebody found it, thought it was really cool, saw that it was free, and then built it into some lesson plans. Is probably what happened.
That's what I'm thinking.
There are a lot of science standards that are being standardized. That was redundant. And I know part of it had to deal with planets and orbits and the solar system. So that may be how that got picked up.
Yeah. That could be, yeah. Eventually I'll update it and try to, right now I don't think you can even use it on mobile. So I wrote it, I didn't even have a cell phone at the time. So I was like, I can't test on that. So no mobile.
Aw, that's unfortunate.
But I think it loads, but the UI elements don't work.
Right.
Controls, I don't think it does, it doesn't do touch.
Yeah, yeah. And designing for mobile can be a whole different nightmare than...
Oh, yeah.
Oh my goodness, things happened.
What happened?
I don't know. I don't have a computer in front of me, so I can't see anything that's what's happening.
We just got a ton of bits.
We just got a ton of bits.
Let me look at the bits. Let me look at the bits.
There's no dog cam, so I can't throw Cheerios at the dogs.
I can make a dog cam occur.
So what happens, what normally happens when we get bits, because you're like, WTF is going on?
I assume it's good.
It is good. Bits is money. Bits are money. Now I can see things.
I'm sorry, I didn't think that through. And I should turn my microphone on. Hold on.
Okay. So she's doing things. But normally we get, when we get bits at home, I started throwing Cheerios at my dogs. So now I have 2 dogs here that know what the sound of bits means. And I want to show the cuteness, but I can't. But, let's see if I can get Eddie. Can you come here? Will you do it for... I know you do it for Mom. Will you come here, Eddie?
And I think you have my audio as well now.
Come on. Oh,
that's a good dog.
Oh, who's a good boy?
He's a
Good boy.
very good boy.
More bits! More bits! This is Eddie. He is the big dumb dog that I want in my future life. Malachi is the poor dog that's traumatized and he's staring because he wants treats, but he won't come to me. All right.
He's afraid.
There, we threw a treat to Malachi. All right. That's it. That's all I have. Oh, thank you, Eddie. Thank you. Eddie's like, you sure? All right. But yeah, dogs for bits.
Yeah.
And Pamela's doing something weird with the camera.
Yeah, no, I haven't affected how you look. You're good.
So, what do you do? I know you mentioned it earlier, but what is it that, can you talk more about the projects that you work on, like, at work?
Yeah. So at work, my main project is the data analysis tool that's part of the sea level change portal. It's the NASA sea level change team as part of the climate efforts to study sea level rise. So I'm one of the engineers. I don't normally talk the science aspect. I leave that up to the experts. Um,
You know
but,
just enough about sea level changes to be dangerous, I'm assuming.
Yes, just enough to write some algorithms for them. So they've got the portal. It's sealevel.nasa, and part of that are some of the tools, and the data analysis tool is is the part I'm responsible for. And we just pushed a new version during AGU last week. Was it last week or?
Yeah, AGU I think was last week. Yeah, it was last week.
Yeah. Some of our managers did part of the NASA town hall, and we pushed out the new version of the data analysis tool for that. And you can go on there. It's the standard mapping application where you can go on there and add data layers for sea level rise, anomaly change, temperature, salinity, moisture transport, and all that. And then there's an analysis tool that allows you actually to go ahead and select those layers, select a region of the Earth, and apply different analytical processes on those, and get a visualization out from that.
So you can essentially go to this site, play around with sliders and numbers, and see what the different numbers would do to sea levels and salinity and so on and so forth. Is that right?
Well, it's existing data. It's not necessarily predictive.
Okay.
So we're taking existing data sets that are curated by the scientists, and you're able to find different correlations and trends among the sea level data.
Okay. So historical data is in there too.
Yes. So
Okay.
if you want to find for like the U.S. East Coast, a correlation or a trend between sea level temperature and or ocean surface temperature and sea level rise, you could do that.
Okay. That's actually quite clever. So you can go back and look at, I don't know, parts of Florida that historically didn't go under high tide and see that, yes, now they get covered during high tide.
Yeah.
Eddie, we got a subscription. Sorry, I'm trying to get more dog. Eddie, do you want a treat? Up. Okay. There you go. Good boy.
Can I have one foot?
He likes this deal.
Oh, yeah. Yeah, no, Eddie was the first one that figured out that basement meant infinite treats. Malachi followed. There's a third dog upstairs who's too afraid of the stairs to come down for the infinite treats, but oh, does she want to?
Because my dog doesn't hear this come busting through the door.
To be fair, third dog, Stella, was inadvertently flung down the stairs during a tornado when the sirens were going off. I was trying to get all three dogs down the stairs, and she tried to bolt while I tried to hold her and walk down the stairs, and both she and I went down 4 stairs at an uncontrolled velocity.
Oh no.
So I might have been traumatized as well.
Yeah. There's been a lot of sitting on the steps with treats and pets, and here's your frisbee. Do you want your frisbee? Anyway.
This is our reality.
Yeah, this is totally our reality. So what got you started in processing satellite, space telescope images for fun?
Well, when I was doing it's kind of a weird route. I don't know. I was doing that elevation mapping software, and then I started using Blender for just actual straight up 3D graphics. In fact, I was helping Fraser Kane do some graphics for his explainer videos. And I was doing that for a while, and then I wanted to start actually processing real data rather than kind of inventing it in Blender.
Right.
So the first thing I downloaded, of course, was a high-res image of the face on Mars, for fun of it. And then I just kind of got straight into Cassini and kept doing that and finding, because the fun of those, it was also a programming challenge. So it wasn't just, because I didn't have a ton of time, because we had just had twins, we had an older kid, So I couldn't spend a ton of time on it. So the programming challenge was to make processing quick. So I had to script it out. So I was trying to automate a lot of the processing. So which I kind of just enjoyed doing with that. Starting with different tools for converting from those PDF archive data to actual images I can work with, or even with the raw imagery, because Cassini was still coming down at the time.
Oh, wow.
With new imagery.
So wait, you pulled data down as PDFs and not FITS files?
It was PDS, the planetary data system.
Oh, PDS. Okay, planetary data system. Okay, I'm sorry.
Yeah.
So you used, and that was I'm sorry, I'm trying to like just process everything. So that's the file extension, or that's where you found everything?
That's where you would find all the archived data.
And then you literally scripted.
I was local.
You literally scripted so you could just do these images quickly. Like, what all did the script do?
The script did half the work. So I would basically it would convert from the archive file format, whether it be Vicar or FITS, and convert it to a TIFF or a PNG. And then I would take those, and of course the conversion was all sorts of different things I'd do it with it there for whatever I needed, whether it be matching output intensities or cleaning it up, removing some artifacts and whatnot, and calibration, of course. And then I would take those output files and then bring them into Photoshop, and then do the alignment and other stuff that just was more need more of a human interaction than scriptable.
Right. I'm just thinking of that workflow versus the workflow I do. I think part of the reason why I like using Hubble images is when I pull them down from Hubble Legacy Archive, they are already all nicely aligned for the most part. So I don't have to do that. And the most I do with conversion from FITS to TIFF is using FITS Liberator and just making sure I can get enough of the details. And to me, I don't know if I could script that. I don't know how comfortable I would be scripting that. How much trial and error?
A lot. So when I switched to a system, I'm doing a lot more programming than I am coming out with good images.
Right.
Which takes time, and it's kind of the opposite of what I want to happen.
Right.
But fortunately, the kids are getting older, so I can still put some more time into it. But even with the Hubble images, I tend to be stubborn too. I've downloaded the Hubble, like the Hubble Legacy ones where they're aligned and whatever. I kind of feel bad when I use that, just because I like to start from the very beginning. And I don't know if the quality, I can't get anywhere near the quality others get on Hubble, but.
Oh no, I end up with some interesting results, and that's with everything all prettily aligned. What I like to compare what the professionals have put out versus what I end up putting out, and usually it is vastly different. And I know that the professionals will spend time doing like the clone stamp tool to get rid of like chip gaps and all this other thing and to clear up a whole bunch of noise, and I'm like, I just want it to be in color.
That's how I started out. I've been getting more into the clone or the content aware fill for fixing and whatnot. But yeah, if I process Hubble imagery, I'm comparing it to others like Judy Schmidt. I compare and I'm nowhere near her level. But the other good thing about it is when sometimes you're doing false color, and there's, as far as I'm concerned, no real rules with how the color should come out when you're doing false color.
Right.
And it's just kind of what the story is you're trying to tell, or what are you trying to show in that data.
Right, because different filters let in, just as a refresher for the audience, different filters let in different wavelengths of light. So if you want to see more of, I want to call it H alpha, but my brain gets things confused. If you want to see more hydrogen, for example, you use a very, very specific narrow band filter, and then you could highlight that with a different color versus the filter that would be used for like oxygen or nitrogen or carbon and things of that nature.
Yep.
I know more ground-based astrophotographers do that than what people do when they capture data on the Hubble, because sometimes the data being captured on the Hubble isn't, and I'm sure on Cassini too, it's not pretty to look at, but it's important.
Yes.
That is what I have learned from working with astronomers that have actually gotten data on or from the Hubble. Because I was like, cool, I'll colorize your photos, and then I was very disappointed.
Yeah, and that's a bit of fun. It's a lot of trial and error. Like with Cassini, you get a lot of the color bands that just by themselves is just, you try to colorize it, does not look good. You're trying to come up with what does and trying to make something pretty out of, just some, random images of cloud formations or whatever. So there's a couple tricks I figured out with that. But.
Okay, what are the tricks? If you want to share them with the world.
My favorite one right now, with Cassini at least, is to take the infrared ones, or near infrared, far red, between the continuum band 2 and methane band 2, and kind of come up with an average between those green. And it actually looks pretty good. And you don't get a strong green, of course, but you get a separation between the highs and lows of the clouds that you really don't see with any other filter combination. It doesn't overdo the amount of data that you're seeing, so it's not overwhelming, but you actually get a good sense of depth within the Saturn's clouds.
That's super cool.
One.
That's super cool.
So as a warning, I'm about to do a bit sync, which means
an alarm's going to go off, which means we could still shower the dogs with treats, but
yeah. It's true. It's true. So, but it does mean the rest of you in just a moment can ignore the amount I'm about to post. Sorry, math is hard. Yes, I do actually have a PhD.
Was that it? Or was that somebody just messing?
No, that was somebody else doing something. Someone just put in bits.
All right, come here. Come here, Eddie. Come on. Look what I got. Eddie's like, really? Oh, my goodness.
Yeah, Eddie sometimes decides to steer the camera. He's good at it.
Right. There's the bits. So the prints that, because I saw somewhere that you're donating some prints for giveaways, which I think is happening now. I don't know. I don't have chat. Oh yeah.
Yes, you do.
It turned itself off.
Oh, I'm sorry.
I give up. I just give up on it because it's like you are not my owner. I'm not going to turn on for you.
I'm sorry.
So what exactly are those prints? Like, I know you're like, here's some rolled up ones.
Yeah. Let's see if I can show these without wrinkling them any.
What are you, dog?
First one is just kind of an artsy view of rings over Earth.
Wait, okay. Hold up. How did you do that? Did you just pull, like, Cassini data and Photoshop it with Earth?
These ones, I took photos that I took, kind of around town here.
Okay.
And two that were just the ISS.
Okay.
So mostly Los Angeles, one of Boston, because Boston's the best, and yeah, ISS. So then I use Blender render out some rings from that general perspective. So
okay.
I made a little simulated Earth. I put the camera facing the rough direction that I was facing, and just photoshopped on on the background. Try to build in some atmospheric effects and whatnot.
And
There's
you
Los
did all the
Angeles.
atmosphere effects and stuff in Blender.
The atmosphere stuff, I did that in Photoshop.
Okay.
And kind of based on what I saw with Cassini imagery. So you see there, as the rings approach the atmosphere, they kind of are bent out. Kind of how you see with the rings going behind Saturn's atmosphere.
Oh, wow.
With, that stuff. And the other poster is I've done a little bit of work with Juno data, and I came up with this technique of creating fisheye views of wherever Juno was at any particular point. So 365. So just it's a.
That's super
Lot
cool.
about.
And part of me is like, is Blender involved in that? I'm looking
It
for
is.
reasons to not hate Blender.
Oh, I love it. It's the newer version, especially. They just pushed out a new version of it, 2.8, and I've been able to do stuff in it that I couldn't before, because before I had trouble coming up with texture sizes and all that stuff in the memory and whatnot. But with the Juno data, I've been following the imagery at full resolution, and that's processed at the native resolution of the closest point to Jupiter to the camera. So,
Okay.
when it maps it out, it gets pretty high resolution. So I've been able to use Blender using high-rise digital elevation models with their imagery, and I've been doing that at full resolution that I've been what they publish it at. So that's like a 250 to 300 megabyte TIFF file for the source image or the color imagery, and usually 200 to 300 megabyte 16-bit TIFF for the altimetry.
Just wow.
Yeah.
Wow. So the audience may know this, but you don't know this. I hate Blender with a passion. I want to see it burn so much. But I have admittedly not used it in several years. When they switched from the classic renderer to Cycles is about when I stopped, because at that point I was still using the classic renderer to do all the things I knew how to do, and Cycles came along and was like, F all of that knowledge. So I essentially have to relearn Blender because of Cycles. But I keep hearing amazing things, but...
Well, they've done it again with Eevee.
Oh no!
They still have Cycles on there, and I switch between whether I use Cycles or Eevee.
What's Eevee?
It's a new renderer they have that does pretty similar stuff. It renders completely, it looks different when it renders. So I haven't gone too far into the differences, but I like Eevee that it renders clouds or just hazes a lot better. It's a lot better at volumetric rendering.
Ooh, that's actually super, super important.
Does
Does
I
it
can
still
never get to work in Cycles.
Yeah.
Always got
Yeah.
really haze.
Yeah. Does it still use the node system?
Yes.
Okay.
Which
So yeah, that's
nodes
the
is
part I
totally
was
great.
struggling.
Yeah. Once you figure out nodes, it's great.
Okay. I may actually have to do this because
Yeah, the latest version's a lot better. They revamped the UI and everything. Since I had dropped Blender, I'd stopped using it back in like 2014. I switched to Maya.
right.
Because I wanted something simpler.
You are not the only Blender user I've heard doing that, by the way.
But you know what? Since I came back to Blender 2.8, I haven't touched Maya since.
Okay. Okay.
So
So all you aspiring 3D artists out there, don't spend money on Maya, just download the newest version of Blender.
yeah. Well, the key was I was using an educational license on Maya.
That makes a huge difference. Oh my goodness.
Yeah, because I was teaching at the time. So I didn't wasn't paying full price for that.
I know. Oh my goodness. So I can't see if the audience has had any questions. Pamela has.
I'm sorry. I will.
She's doing a gazillion other things. Because I'm sure there's been questions. I'm sure there's been comments from the Peanut Gallery, especially on my hatred of Blender.
So Larry comments on the rings. Is that the year 3166? The rings around the Earth. So the idea being that the moon got obliterated.
Oh, I was joking about that on Twitter when I first started posting them.
So yes, Larry.
I was joking, oh, it's too bad that the moon had to get destroyed, but honestly, it had it coming.
Fair. So Rigel16 asks, what's one or some of your favorite projects that you've ever done, Kevin?
The favorite thing I've ever worked on was when I was during Cassini's grand finale. I was actually working for the Cassini outreach team, processing the imagery as it came down. So I was doing professional image processing at that point. And the images came down from when Cassini took a mosaic or a wide field view from within the rings. And it's not much for an image by itself, because you see kind of a little teeny bit of the limb, and then the kind of the rings come around. But when the data came down, I was processing, and I realized I'm the first human to see Saturn from within the rings like this. Wow. And for the rest of the day, I'm just like, I saw that. And, it was just, it was really neat to do that. And then I was also, the day that Cassini was deorbiting, I left work, came home, and I was grabbing all the images as they were coming down from the spacecraft, the final images, and processing those to get them out to the media. So while everyone was, a lot of people were celebrating Cassini or getting ready for her demise, I was processing all the final images.
That's still, that's just super cool. Being the first human to see Saturn from within the rings.
Yeah, that would.
yeah, I think I would have just been mind blown too.
I think I had to get up and kind of walk around for a minute to ingest what that I was seeing that.
So all of those mosaic images had to be aligned. How did you do that? Did you do that by eye? Did you use one of your scripts to do that?
The script went and, they'd converted it to the image like I normally do, and then kind of matched the brightnesses of them, so I wouldn't have to go, this one's a little darker. So it automated that, and then removed any geometric distortions or camera stuff. And then, I brought them into the Photoshop and aligned them there. Because, while I was taking those pictures, Cassini, it wasn't one of those sports photographers with a rapid fire camera. So it was moving while I was taking those pictures. So they would take a little bit of puppet warp or whatever in Photoshop to get, fix up their alignment a little bit to get into a smooth image.
Yeah, I wondered how you would compensate for the movement of the camera, because it's, as you said, it's not rapid. Sometimes the shutter's open for a while. Yeah, and I know I've noticed that when I've tried to play around with images of planets, that the shutter's open for a while and everything kind of ends up blurred. Yeah. So I pick the middle observation. So where Cassini was in the middle of the whole thing, and then kind of blended it to that. Oh, that's good. Because if I picked just the first one, the last one would be really distorted. Right.
So I just kind of go somewhere in the middle and just kind of bring it in.
did you have any arts training at all? Any photography training? Or is this just, okay, so you're just one of those people that's just like, oh, okay, this looks good. We're going to do this.
Yeah. Yeah. And it's taking trial and error and a little bit of, I hope this looks good. I hope people like it. Because I don't know. I could publish something and just a pile of garbage, and I don't know.
Or you think it's a pile of garbage, and people are like, no, it's great. It's great. And you're like,
It has been that.
yeah, I don't know about that one. So what's been your favorite, aside from the Cassini, what has been your favorite project to work on for image processing?
I've been enjoying Juno quite a bit because that's even more. If you've ever seen a Juno raw data, it's fun. So
I think I've looked at it and was like, I don't know how to handle this the way I'm used to handling Hubble images, and noped out. I think I noped hard.
Yeah, and I did. I was like, no, this is going to take me too much. But I ended up being able to script it out and get it working. And I challenged myself I was like, for each perijove, so Juno goes past Jupiter every 52 or something days. And I challenged myself, all right, for each one of those, I'm going to have some measurable improvement in how I do this. So the first one, I kind of just randomly or just placed the image strips together for the script and called it a day. The next one, I needed some little bit smarter on where it was placing it. And eventually I just got it to where, it's just straight mapping the entire observation and putting it all together automatically for me.
So your JunoCam script matches the brightness and contrast between all the images, and it does the placement.
Yes. And it does the placement by virtue of the mapping. But the rendering I also in Blender. I got my money's worth out of Blender.
For those that don't know, Blender is free.
Yeah. So yeah.
I'm so sorry to be giggling in the background into the microphone.
So
it's a good statement, though.
So I got the script, outputs the map images of Jupiter, and then comes with some metadata that I have another script in Blender that'll read all that in and build out the scene for me and place the camera. And if I'm like, right there, if I'm happy, render. Otherwise, I can move the camera around and do what I need to do or do what I want to do to make it a better picture.
So I'm assuming the Blender script is Python, because I know Blender plays well with Python.
Yes.
So did you do all of this in Python, or did you use? It is all in Python. Okay. Okay.
All in Python. The third-party libraries, those are in C++. So I bring in some stuff from the USGS ISIS-3 software, which I wouldn't have JunoCam processing if it wasn't for them. And then there's some regular shell scripting and whatnot. So,
do you use PyRaf at all?
I do not.
Good. Do you use IRAF?
No, I don't even know what those are.
Okay, no, that's fine. It's fine. IRAF was killed after being used for many, 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 many years, and I forget what language it was in. And then they tried to replace it with PyRaf, and there was a very intense search, or it was a frenzy, a very intense frenzy amongst astronomers looking for old IRAF documentation, because they took it all down. Oh. They didn't even leave it up for archival purposes. They took everything IRAF related down, because they're like, everybody has to use PyRaf now.
And those of us who grew up using IRAF cried.
Yes, because IRAF is not easy to use, which is why when you're like, I don't know what those are, I don't use them, I'm like, good.
But those of us who were IRAF fluent, who learned how to code our own routines because we're broken in a very special way, the complete removal of IRAF from our reality was Sad.
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 Sad. Oh, I have chat back now, maybe.
You have chat back.
So I'm going to see if there's any other questions. I have no idea if there are. Guys, it's okay to ask questions.
Our next guest is going to be David Joseph Wesley, who actually wrote an entire CD of music about the Cassini Grand Finale, and we're going to be talking about that music and playing some of it in the next segment.
So, Larry, say again?
So speaking of Cassini and music, someone took one of the Cassini images that I processed for the mission of the rings and made it into a harp. I think
harp?
It was on I think of the astronomy picture of the day at one point, and you just kind of run the mouse across the rings.
They did sonification.
Yeah, it was awesome. I love the tool.
I love sonification.
Yeah, you just play the rings and you just kind of do it however you want. It's really great.
That's cool. Larry is making the comment about free software saying, yes, if GIMP was not free, no one would use it.
This is true.
I'm not going to sell out GIMP. I used that for a long time.
Okay, Trekker Kev has a question. I think somebody else had a question, but they didn't put it in the thing. You were breaking up when you were explaining the trick with the Jupiter bands and the Earth. Can you repeat that?
The Jupiter bands and the Earth?
When you put bands around the Earth and it looked like...
Oh, the rings?
Yeah, I'm sorry.
I'll be right.
I am trying to process things.
So I have a model in Blender. It's just a simple sphere with the rings around it. And I just plop the camera down onto wherever I took the picture. So I've got the camera sitting on Los Angeles where I live. I've got another camera sitting in Boston where I took one of the pictures. And just kind of angle that to look at the rings at roughly the same direction that I was taking the picture. So I was being kind of stubborn. I didn't want to take a picture where I was actually like facing north, like anyone would know,
right.
and process and do it with that. So it would just render out the rings transparently with a transparent background, and I just kind of Photoshop it onto the picture. But the trick there is on the layer you set it as additive, not like a normal type thing, and then you get an effect where it's not going to look like you're dimming through the atmosphere, which is not what they would do.
Right.
You know, something outside of the atmosphere can't make our atmosphere dimmer. Unless it's actually blocking the sun.
Right.
So.
All right. Trekker Kev asks, what kind of home workstation do you use for image processing?
I either use the MacBook that I'm on right now, or for the heavier rendering, I got a larger PC that's running is not built for gaming, but it's got a GPU, the NVIDIA Tesla GPU, dual GPU that Blender renders on.
Fancy. And chat has just broken for me, apparently.
Yeah, about 64 gigs of memory. So it
64 gigs of RAM. Is that like RAM or is that video RAM, like on the graphics card?
No, that's just regular RAM.
Okay. I was like, 64 gigs of video RAM? Oh my goodness.
Yeah. And it's the rest of it's pretty hefty. Got the hookup from my father-in-law who helped me build it. So put it together and it's pretty good. That's what I'm looking at if I keep looking up.
Is your rig?
I've got your public stream up there.
Oh, okay. Okay, that makes sense. It totally makes sense. I was given a MacBook that's not fair. Trekker Kev says 64 gigabytes choke. There may have been some tea spitting in the audience. Walker says that he would kill for that much RAM. Walker is a gamer. Trekker Kev goes on to say that his image processing PC has 2 gigabytes and he's looking forward to bumping up to 4 gigabytes. Trekker Kev, I feel you. There's part of me that's like, I may even be able to donate some old RAM depending on your build. Oh my goodness. So does 64 gigabytes of RAM really make that much of a difference?
Yeah, I can process stuff at full resolution, especially when I'm pulling down like the full high-rise stuff, or Juno, or when I'm actually rendering videos, because then I don't have to swap it out to disk.
Okay.
So you get a lot better performance that way.
Do you have any solid-state drives, or is everything the old school disk drives?
4 terabytes of solid state.
All right, now I'm envious. I was like, 64 gigabytes. Yeah, I can aspire to that someday. Well, but I think I have 1 terabyte of... No, I don't even think I have a terabyte of solid state.
Yeah, and most of those are being used because each time I render these high-rise videos that I've been doing, I've been keeping frames because eventually I'm going to get around to making kind of a movie out of them.
Mm-hmm.
I have no idea how or what I'm going to do with it. But I know I'm going to keep them, and I'm going to do it eventually. I don't know if I need to get a writer to talk over it, or if I'm going to use, some ambient music or something. But
ambient music is always a safe bet. Ambient music is always a safe bet.
Yeah. I've used it before, but I figure there's stuff to learn and talk about with some of these videos. I just don't know what to say.
Right. Eric 1 says that he has 32 gigs of RAM and he's seriously considering adding more. Somebody else says that they bet you could run Kerbal Space Program nicely. And for those that are watching, that's why he prefaced this with, this is not a gaming computer. Gaming computers and image processing computers and video processing computers often have the same kind of specs for different reasons. And yes, it can be a multi-purpose machine if you do game. But
it's Kerbal, but I put it at the full resolution. Just because, the main GPU for on-screen stuff, that's just it's an onboard Intel GPU.
Right.
So
then Refsmet has a comment about Juno's camera isn't actually a science camera, but it produces really complex images.
Yeah, it wasn't intended as a science camera. Can't be calibrated. But it's to kind of knock it a little bit. It's kind of a glorified dash cam. It's a wide angle camera. But yeah, we've been able to get some good stuff out of it. A lot better than I think was expected. And some of the science teams have been able to derive good science from it. Actually, I think they've kind of like, after the fact, kind of retroactively said, "Oh, science camera," which is great.
Yeah, that's always great. Always, always, always great. I can't really read the text. Can you briefly explain what high-rise is? Somebody asked what it was, and I know you probably understand it way better than I do.
High-rise is the high-resolution imaging camera on the Mars Reconnaissance Orbiter. So they've got, spy satellite levels telescopic camera over Mars. What I've been told is that you couldn't have it on an orbiter on Earth and not have the government mad at you. But basically, it has some different filters on there for imaging Mars at very high resolution. Their color imagery is down to a meter to a couple tens of centimeters per pixel.
Wow.
And then they could take that data and either do infrared type ultraviolet type images or RGB, though it's not full true color.
Right.
They can combine them into anaglyphs for 3D viewing, and then digital elevation models for actually getting 3D views. And that's what I've been combining for the some videos and still shots. I made a kind of a an image series that I was just trucking around Mars with the camera. Kind of fun that way.
Keeper of Maps says, so spying on Earthlings not okay, spying on Martians okay.
Yeah, forget them.
Yeah.
Yeah.
I think we're running out of time. So do we know if David Joseph Wesley is ready?
I need to call him up on FaceTime.
So we actually have to switch technology because Zoom was not designed well for low vision or vision impaired. So, but FaceTime is, which I find a little ironic. So we're eventually going to swap up technology and swap out hosts because, yeah, I wanted to geek out. Thank you for letting me geek out with you.
Oh,
I really appreciate it.
I
have a feeling Pamela would have asked a whole different set of more scientific questions, and I'm like, computers? I like computers.
Thank you for the 25. Sorry, my mic is turned off. And you are awesome, Canada Kim.
All right. So I guess any parting words?
No. I just good luck to you guys for the hangout-a-thon. It's an honor to be on here. I've been watching CosmoQuest your streaming stuff for years. So.
What?
Yeah.
That's super cool. Thank you for all of your support. Thank you. I don't know how to do anything, so I'm just going to awkwardly sit here while Pamela fixes things. So again, thank you so much for coming on. Thank you for your generous donation of your very, very awesome prints. I don't know who won what. I can't read chat very well.
Yeah, just let me know where to mail them. So
we will totally do that. That is going to be handled by myself, Susie, or Nancy. At some point, we will tell you where to send them. But yes, thank you very much for both your time and your generous donation of your art. So yeah, that's all I have to say. So bye.
All right. Bye.